These are the topics. Today we are going to learn how to declare a structure, accessing structure elements, how structure elements are stored, array of structures, and structure as a function argument, and returning structures from functions. Now, structure is a group of different types of variables, and that group is represented by a single name. For example, if we need to store the information about 50 students, information like their class numbers, semester numbers, and CGPAs, so we can have two approaches: a combination of array where we need the first array to store the class number, second to store the semester, and third to store their CGPAs. Now, the main problem with this approach is to link these arrays for the information of a particular student. While in the second approach, the structures all the related data about a student is grouped and having a single name. A structure is basically a derived data type which contain members from fundamental or derived data types. So we can have mixed type of data in a single structure. That's how we define a structure. Struct is a keyword followed by the name of the structure, start of the definition, end of the definition, followed by a semicolon. These are the variables. Types of variable and number of variables depend on the requirement of a structure. We have to follow the same rules for naming a structure, the one we use for variables and functions. This is a sample structure here. Struct is a keyword, book is the name of the structure, and in this structure we have four variables, two integer and one array, character array, and the fourth one is float variable, and that's the end of the structure. In this example, we will demonstrate how to use a structure in a program. We have one structure here. The name of the structure is CSC20, and this is the structure definition, and these are the members of the structure. This is the name of the variable, and the type of variable is CSC20, and CSC20 is a structure. So basically this is a variable declaration. It's very similar to declaring a variable of the integer type or float type, where we write the type of variable and then the name of variable. In this case, this is the type of variable. So struct CSC20 is a structure. So this is type and this is the name of variable. So Najib is the name of the variable. So we know that we have three parts of this variable: the semester or SEM, and CGPA and CN. So how we use those members of this variable? So we have the operator here, the dot operator or member of operator. Najib dot sound semester, so semester is 1. This is the assignment operator, so you're familiar with the assignment operator. Then Najib dot CGPA, so the CGPA is 2.4 and the class number is 12. And that's how we access the members of the structure. And then in the same fashion we can use those operators or the member of operator to access or to for the displaying the values of these members. So this is the output of the program. It's very simple. The same example with a different approach. Here in this example, we are declaring and assigning the values to Najib variable in one statement. So this is the variable declaration. This is the name of the variable. This is type of variable, and this is the assignment. So the first here inside the curly bracket, the first value will go to the first member. The second value will go to the second member. So of course this is float. So the float value, then third member, the third value, it go to the third member. So instead of writing or assigning these one by one to individual members, we can assign the values in one statement, and that's how we access. So it's the same example with a little bit different approach, and that's the output. It's the same output, the one we saw on the previous slide. Same example with a different approach. Here in this example, we are writing the definition, declaration, and assignment in the same statement. So this is the definition of the structure. This is the name of the variable, and this is the assignment statement. So it's the same example, the one we discussed on the previous slide. So the same output. Here in this example, we will demonstrate how to use the assignment operator with these structures. So this is the structure, and we have two variables of the structure, A and B. For A, we have the values 1, 2.4, and 12, the same we discussed in previous slides. So these are the values for the first variable A, and the values for the second variable B, those will be assigned from the A variable using the assignment operator. So it is very similar to use the assignment operator as we use for the basic data type, like for integer or float values. So you can see you will get the same output. In this example, we will demonstrate how to use pointer for structures. So the same structure, the one we use in previous example, CSC20, and these are the members of the structures. And we have the name of the variable is Ali, and the values are 2, 3.4, and 32. 32 will go to CN, 3.4 will go to CGPA, and 2 will go to the semester number. And the name of the variable is Ali, and the type of this variable is CSC20, which is a structure. This is the type, this is the definition. Now we have to declare one pointer variable, and the type of this pointer variable should be the same. So this is the pointer variable. It's the same approach we are using. If you remember, uh, you have to put a static in front of the name. So this is a pointer variable, and the type of this pointer is this one. So on this pointer variable, we are assigning the address of this variable, and we know that this variable is a structure. So the the address of the Ali, that will be stored on this pointer, and how we access those individual members. So this is the operator, referred as the arrow operator. So you can see that the semester number will be displayed 2, and the arrow operator CGPA, that will be displayed 3.4, and the class number will be displayed here using the same operator. So that's how we use the pointers with structures. Another example to demonstrate the pointers with structures. In this example, the same structure, the name of the structure is CSC20, and we have two variables. The name of the first variable is Ali, and the name of the second variable is Asad. The values of Ali variable are 2, 3.4, and 32, and these are the values for Asad variable 3, 1.9, and 11. And we have a pointer variable, and the type of this pointer variable is CSC20. So here we have assigned the address of Ali variable to this pointer, and we are accessing these values. So you can see 2, 3.4, and 32. That's the output of this statement. And here in this statement, the address is now the address has been changed, and now we are using the address of Asad variable. So you can see the same statement, this printf statement and this one, they're the same statement and using the same operators, but they are having different outputs because this pointer is now connected to this variable, or in other words, uh, this is pointed to the semester of another variable. And here in this case, the address is different, so this is pointed to the semester of this variable. So it's very simple, very similar to the concept, the one we used in the basic data types like integer and float, etc. In this example, we will try to demonstrate how to use array of structures. This is the structure, the name of the structure is student, and these are the member of the structure. And now we have array of structures. The name of the array is CSC20, and the type of this array is student, which is a structure. The size of this array is 4. In other words, we have 4 structures, CSC20 index 0, CSC20 index 1, CSC20 index 2, and CSC20 index 3. And now we have 4 statements, and we are trying to assign some values to the CGPA members of those structures. So we are calling those structures randomly. So first 2.3 will be assigned to the CGPA member of the last structure because the index is 3. 1.6 value will be assigned to the second structure CGPA. 3.4 will be assigned to the CGPA member of the third structure, and 2.8 value will be assigned to the CGPA member of the first structure. Next, we have a for loop. The value of y is 0, and that is true, so we will execute this statement. So that means that we have here CSC20 index 0, so that means the CGPA of the first structure will be displayed, which is 2.8. When the value of y is incremented by the loop, now CSC20 1.cgpa, that means the CGPA of the second structure. So the value of the CGPA of the second structure will be displayed, which is 1.6. You can confirm here. Then CSC3.cgpa, so 3.4 will be displayed. Then CSC, the last one, 3.cgpa, the last structure CGPA, which is 2.3, this one. And that's how all the CGPA of all the structures will be displayed. Similarly, we can display the semester number of all the structures, or similarly we can display the class number of all the structure using this. We need to change only this part because that is the member of operator, and any member can be called using this for loop. So it's a very simple method to display a single member of all the structures. This example shows the value of the structures and the structure. This is the structure variable and this is the area of the structure. Here we will learn how the structure member are stored in the memory. So actually contiguous and adjacent memory locations are used to store structure members in the memory. In our example, we have the structure. The name of the structure is CSC20 with three members, SEM, CGPA, float, and CN, another integer. And you can see here, this is the integer variable, the float variable, and integer. They have the adjacent memory locations. In other words, we can say that these are the memory locations which are assigned to CSC20 structure. So all in all, 8 bytes are reserved for CSC20 structure. And if we have another CSC20 structure, then another group of 8 bytes will be reserved after a few adjustments in the memory. Another example, how to pass and return structure from a function. Now in this example, it's almost the same example, the one we discussed on previous slide, but here in this example, this function, STF2 function, it can receive a structure variable and it can also return a structure variable. But remember this, the type of the structure should be STUD, because we have the definition of STUD here. So this is the function definition. You can see here the x dot sim will be incremented by 1, CGPA will be incremented by zero point 0.5, and class number will be incremented by 7 by this function. So whatever structure it will receive, STF2 will receive, that will be incremented, the members will be incremented accordingly, and then it will send back that function. This function is not displaying the value this time, and the main function will display. So let's go to the main function. We have the same variable name, structure variable name, asif, same values. 3 will be assigned to the semester number, 2.4 will be assigned to the CGPA member of the asif structure, and 50 will be assigned to the class number member of the asif structure. Then we are sending this asif structure to the function, which function, STF2, and whatever that function will return, that will be stored on asif. And we know that asif is structure, So that means that this function will return a structured variable, and yes, we know that this is the type of those structures. So Asif, here you can see that this is passed to the stf2 structure. So that this Asif variable that will be stored on x. So now x dot sim, which was 3, so that will be 3 plus 1, so that will be the value will be changed to 4, and then the CGPA was assigned 2.4 by the main function, and then after passing to the STF2 function, this will increment by the CGPA by 0.5, and it will increment its class number by 7, and it will return x. So you know that the x structure, it will come here to the main function and it will be stored again on the ASIF. And when you display the values of the members of different members of the structure, so asif.sim is now 4, asif.cgpa is now 2.9, and asif.cn is now 57. So here you can see that we assign these values, then we pass this structure variable to the function, and this function stf2, it it made some changes and assigned to those members, and then the whole structure was sent back to the main function here, and it was assigned to the asif. And when we display the values, and these are the modified values, so it's pretty simple. You can pass and return structure to